Alright, so we have here another word problem, and this time we're actually going to go through and solve it. So again, we start by trying to analyze the question and what variables we know. So right off the bat it says he averages a speed of 7 meters per second. So we should write down V bar is 7 meters per second. That means the average velocity in a 100-meter race. Again, remember M stands for meters, not minutes. So that means the distance he's going to run is 100 meters. How long does it take him to complete it? We are looking for time. So we need to find an equation that has these three variables, and what do you know? It's the first one. So we have all those, so now we can kind of start plugging in. So assuming the units all match up, meters per second matches up with meters, like they'll cancel. We don't have to do any conversions, we can just kind of plug in. So the average velocity is 7, and delta x is 100, and time is unknown. My advice in solving something like this, anytime there's a fraction, is to just cross multiply. So put 7 over 1, we'll cross multiply. So 100 times 1 is 100, equals 7 times t, which is 7t. And then we can divide both sides by 7 and get that t equals 100 divided by 7, 14, I'm going to round a little bit, 14.3. And the units will be seconds because meters per second in meters, the leftover unit is going to be seconds. We can talk about how that cancels. If you do meters divided by meters per second, it's the same as saying meters times seconds over meters, which gives you seconds. Anyway, that's the answer. Time is 14.3 seconds. One thing that might be useful to do is double check this. A lot of people make mistakes in this algebra, so what you can do is go back into the original equation and plug in the numbers. Delta x was 100. And delta t, time, is 14.3. And if you divide these two things, you should get V average, which is 7. And when we do that, it checks out, so that means we've done it correctly. It's really common that people divide this the wrong way and they get the wrong answer. So just check your number when you're done. Alright, here's another problem. Same thing, we're going to set it up. So a race car accelerates from rest. So that means that it began at a speed of 0 meters per second. At a rate of 10.5 meters per second squared. That tells us the acceleration. And it wants to know how fast it will be going after, so it wants VF, 100 meters. Again, that is a displacement. So now we look over, we try to find an equation that fits all these. 1 and 2 are out quickly because there's no average velocity. 3 is no good because we don't have time. 4 is no good because we don't have time, so we're looking at equation 5. So all the units seem okay, meters, meters per second squared, they're all going to basically cancel properly. So we'll plug in our numbers. VF is unknown, so we're going to leave it as VF squared equals VI squared, 0 squared, plus 2 times 10.5 times 100. Okay, so we're just going to simplify that. So 0 squared is 0, we can ignore that. So 2 times 10.5 times 100 gives me 2100. Now that is VF squared, so to find VF I take the square root of both sides, and so that means VF equals the square root of 2100, which comes out to 45.8, and since this is a velocity and we didn't have to do any conversions, it'll end up being meters per second. So that is our final velocity. And again, if we want to double check that, we can plug back into our original equation. 45.8 squared equals 0 squared plus 2 times 10.5 times 100. And if that's pretty close, you know, there's always some rounding error, then we've done it right. And if I do that in my calculator, it checks out. So that means I've done it correctly. So again, that's how we solve a word problem from start to finish. So until next time, I am Derek Genova. Have a delightful day.